Now, once we have established this object, which is a function, through looking at relationship between sets or smaller objects, now the natural question is to build upon them and look at what can I do with these functions. And so the first natural question is, what operations can be performed on functions? And it turns out these operations that can be performed on functions are the same as those that are performed on numbers. Meaning that the sum of functions acting on x is the same as the sum of functions. Similarly, the difference of functions is the same as difference of functions. The product of functions is the same as product of functions. And the division of function is the same as division of functions. Now over here, you have to be careful to say that gx is not equal to 0. So essentially what this is saying is, these are just numbers, f of x and g of x. These are outputs which are numbers, and so they follow the same rules of algebra as numbers follow. Now, actually here is one topic which I think I forgot to include in the lesson plan, so hopefully you are watching the videos. This is called finding domains from algebraic expressions. Okay, what does that mean? We use this term called valid input. Okay, so which raises the question of then what is invalid? So now what the answer to what is invalid depends on what level of math you're studying, in the sense that there are many invalid operations, but you may not know about them. So the most obvious ones that you need to know is that, for example, division by 0, and at this point, square root of negative numbers. Now there are we're going to add to this list as we learn more functions like logarithmic functions and trigonometric functions and all, which you will learn in the future. You add to these definitions. So the most basic ones are these. So let's look at an example. Let's say I have a function which is 7 over x minus 5. And I want to find the domain of this function. Now remember, domain means the set of valid inputs, which means the x values. Now over here, when you look, you can plug in x to be anything except 5, right? So what you have to recall is that division by 0 is invalid. And division by 0 occurs when x minus 5 is 0 or when x is 5. So my domain in this case, if I try to draw it on the number line, is everything except 5, right? So the domain is all numbers except 5. So if I have this number line and I put 5 in there, that's going to be a hollow dot here and everything, and then everything, which would be negative infinity to 5 round union 5 to infinity. Another example would be square root of, say, x plus 3. Now here, for valid inputs, we need that this is greater than or equal to 0. meaning it's positive or 0 because square root of 0 is 0. And that gives you x is greater than negative 3. On the number line, that would be negative 3, and then because it's equal to, this would be solid, and because it's greater than, it would be to the right. So square bracket at negative 3, infinity. Okay, so the two operations that you want to be careful about so far is when you have a division involved and when you have a square root involved, because that changes the domain. Now you may have a complex example of, say, divide. Yeah. So here you have to be careful. First, because of the square root, you need x minus 2 to be greater than or equal to 0. But you have to recall that x cannot be 2 because that makes a division by 0. That creates a scenario of division by 0. So here is 2. When you're figuring out your domain, you cannot be 2 and you have to be larger than 2. So it's 2 to infinity. Okay, so I sort of took a little segue here on like a departure from what the lesson plan said. So I'm going to end this video at this point, and then we have compound functions to talk about in the next one.